7 billion years ago, the universe was smaller than the smallest part of an atom. Unbelievably small. Then, something happened. In a flash, everything suddenly expanded. This was how it all began, the first moment of existence, what we now call the Big Bang.
And that's what we know to be true, not because theorists have invented it, but because all the observations tell us. We can predict the abundance of light elements, and they agree over 10 orders of magnitude with what we see. So that fundamental picture that the universe is expanding and emerged out of a hot, dense universe, a finite time in the past, is the Big Bang picture.
The theory of the Big Bang isn't the sort of thing you figure out overnight. It takes years, centuries of collected wisdom. Mankind has been thinking about this for a long time. Even before we realized it, we were thinking about it. Every time we looked up at the stars, we were thinking about it. How do we know what we now know? How did we figure it all out? That's the heart of our story. The story of how our concept of the universe evolved.
We stockpile the discoveries of the most brilliant members of our species, allowing us, however strained and with whatever struggle it involves, to slowly ascend the ladder of knowledge. Maybe compensating for the fact that any one of us is just too stupid to figure it all out.
So, where do we begin? Today, professional astronomers and physicists on campuses like the Massachusetts Institute of Technology and Cambridge University in England wage debate about the Big Bang theory. But the conversation began a long time ago, before anyone ever heard of the Big Bang, before anyone knew what the heavens really were.
Way before science existed or was even a contemplation in the minds of anybody, people were asking questions about origin.
When early man looked at the sky, he saw it dominated by the warming, life-giving sun. At night, he saw the moon and stars. This was the universe, harsh, hostile, and chaotic, with a drifting sun that shifted across the sky as the seasons went from warm to cold. Primitive people needed to understand the world in order to survive it.
People had absolutely no control over nature. The balance of the expected and the unexpected made people make nature into gods in order to establish some kind of relationship with them.
Without telescopes or modern observatories, primitive people relied on simple structures to help them understand the skies. At places like Stonehenge in England or Chichen Itza in Mexico, they attempted to connect with the heavens, the perceived home of the gods. These were simple instruments of observation and tools of analysis that helped make sense of the dancing universe.
We are here in the eastern part of Germany, some 100 kilometers south of Berlin, in a little village called Goseck. One of the oldest monuments concerning sun, moon, and stars was found here. This is the solar observatory at Goseck. It was built 7,000 years ago and was used by the early farmers to tell the time in the year.
Constructed 2,000 years before Stonehenge and reconstructed here, this is Europe's oldest known calendar, During the winter and summer solstices, the shortest and longest days of the year, the setting sun lines up with gates in the Palisades. Knowing these dates helped these people understand the life-giving sun.
The night sky is a clock. It is a gigantic clock staring you in the face, and it allowed the ancients to calculate when to plant, when to harvest. In other words, their very livelihood depended upon their understanding the motion of the sun and the heavens.
This idea of astronomy predicting the behavior of the natural world based on the motion of the heavens gets mixed up with the dogma of astrology, the belief that the motion of the heavens predetermines our fate, that a meteor signals military victory, a new star, the birth of a king.
Back then, astronomy was predicting the motion of the stars. Astrology was predicting how those stars affected us. And it's really hard in the ancient mind to separate those two. That if you understand the clockwork of the heavens, you understand how our fate is going to be.
Astrologers divided the sky into regions as early as the 6th century BC. They saw shapes in the stars and named the regions after these shapes: Aries, Taurus, and Gemini, among others. But as astrologers gazed at starry skies to divine their fate, they also watched and learned how the heavens moved. From superstitious motives came the baby steps of scientific observation.
I see science as a journey that our species has been on for roughly 2,500 years to try to come to grips in as deep a way as possible with the universe, the laws of the universe, the structure of the universe, what makes things up, how do they evolve, and what are the forces that govern change.
But sometimes, simple observations can lead to fundamentally wrong conclusions. Using mathematics, the ancient Greeks provided more detailed information about our dominant celestial neighbors, the sun and moon.
Even back then, 2,000 years ago, they knew that the earth curves. And by looking at the shadows, they calculated the size of the earth to within about 10% accuracy. They actually calculated the distance from the earth to the moon and the rough dimensions of the distance from the earth to the sun. So in other words, the ancients were no fools.
The ancient Greeks also recognized two types of stars. Most were fixed and small and moved together. A few were larger and moved haphazardly, or so it seemed. These were planets, and predicting their motion became a centuries-long goal. With just their naked eyes to scan the skies, the Greeks saw only 5 planets, naming each after their gods. Today, we're more familiar with their Roman designations: Mercury, Venus, Mars, Saturn, Jupiter. Ancient astronomy assumed a concept of the universe proposed by 4th century BC Greek philosopher Aristotle, who imagined the Earth at the center of the universe, with the sun, moon, stars, and planets all revolving elegantly around it in perfect crystalline spheres.
Aristotle's universe was finite. It was a big sphere. Actually, it was like onion. It was an onion with many concentric spheres.
1st century astronomer Ptolemy improved on Aristotle by accurately tracing the paths of the planets, which didn't move haphazardly after all. Using complex circular motions called epicycles, Ptolemy could predict their prescribed paths and changing velocities. In other words, Ptolemy's system reliably predicted the future behavior of the planets, another step in in man's journey to understand and control the universe.
The Ptolemaic system was extremely complex. It had all these planets going in loops, and it worked beautifully, but it was just wrong. The idea that you can predict something doesn't mean you understand the fundamental principles behind it.
Ptolemy's system did not accurately reveal the universe, but it didn't try.
He essentially showed that the positions of the planets could be calculated for any time past or future. It was a tour de force of mathematical understanding. Interestingly, the astronomy seemed to stand still for centuries after that.
In fact, after the collapse of Rome in 476 AD, astronomy actually lost ground.
Europe fragmented into smaller powers, and a lot of the wisdom of the Greeks was lost.
1,000 years later, a new theory would confront accepted beliefs about how the heavens worked and would move mankind one step closer to a theory of the Big Bang. During the 15th century AD, an idea called heliocentrism claimed the sun, not the earth, was at the center of the universe. This horrified Christian clergy who felt it contradicted the Word of God. If God created earth and man in his own image, then earth and its devout inhabitants must be the center of everything. Ironically, the champion of a sun-centered universe was a devout church deacon from Frombork, Poland, named Nicholas Copernicus.
He was a cathedral administrator, working to help collect the rents, helping people who were sick. But in between, he was working on astronomy.
Copernicus was troubled by Ptolemy's complex heavenly mechanics. But he found an elegant solution. When he moved the Earth from the center of the solar system and replaced it with the sun at the heart of it all.
When Copernicus put the planets going around the sun, he discovered that the planet Mercury, which goes around in about 3 months, automatically fell closest to the sun. And Saturn, the slowest planet, which goes around in about 30 years, automatically fell at the outside edge. Copernicus wrote,